Hello academics class Tabangitegla, welcome back to Caltex Academy. Clearly this series we're looking at Swiss angle. This is video number 2 of the series that you don't go on. I've left a link in the description of our video, or you can check the cut up here and also opportunity number 1 of this series. I'm going to teach you how to rate Swiss angles with a using calculator, and please to watch until the end of this video because I'm going to give you 2 Swiss angles that are included in our list here. I'm going to teach you towards the end of this video on how to remember this special angles using the table. So please stick around until the end of this video. We'll understand now. In this special angle about so on, video more to special angle yet another clips Caltex your grounds out. I will work with step by step on how to get this question angle. And if it's same an examination where the talk about that is in calculator, there's something in the fact it is special angles. So let me walk us through these 2 triangles. The first triangle here is equilateral triangle. And equilateral triangle there is, we have the same side and also the same. And we'll see what this only so there. This might not be accurate, but simply, yes, we can assume that these sides are all the same, around going to say the angles are the same. So if this side are the same, we can do something like this to decrease the enemy, but the sides are the same. And perhaps they will take like 2 minutes, and takes this one. Alright, yes, also 3. Unique, so from there, this angle is 60 degrees. This is 60 degrees. But remember, if we debate this triangle, we change from the little here, we broke it into the upper sector, this triangle. We'll also have this angle divided into 3, because the angle happens with 6 for equal to triangle, or the angles are the same. Now, if this is 90 degrees, also this one will be 90 degrees. Perhaps this also included here. And we have that as 90 degrees. This particular dissector divide the angle into 2. Therefore, we have here 30 degrees. On this side also there are always 30 degrees. So we're free to select any of this triangle to start with. And let me let this as A, V, and C. As the vertices this triangle, then we connect this one as N has the point of the perpendicular bisector secant divided clearly into 2 equal parts. But this one is equals to this plane. And if the length when A have to D is 2 units, meaning from A after L would be 1 unit each. Cos the sum of this AL plus MD equals to AD. And that is 2 units. Now after this, we also need to take one of these triangles because all of them are the same. So you can decide to take ACN or DCN. Now, what is this? Let's with ACN and take this angle 60 and over with on our trig ratios that with sine. So let's start here. Sine of an angle 60 degrees, and we go to it cosine of an angle 60 degrees, and also we to tan veil of an angle 60 degrees. So yeah, that tan veil cosine sine of angle 60 we can transfer to 30, and we have sine of 30 degrees. In new pay or sine of 30 degrees, and lastly tan of yourself 30 degrees. So before we look at these special angles on how they can get their values, that is a calculator, we also need to get this distance C and M. How do you get this distance C and M? Here we can use photographs theory, where Cn square is given by a sin square minus LA m square. So from there, we can make substitution where our cn square is given by a sin is 2 units. C square that minus an is 1 unit. We square 1, and here the line have 4 minus 1, and this is cn square. So we subtract 1 over 4, we get 3, and therefore cross cn square is the same as 3. So to get cn alone, we get to square it on both sides, such that we have it has the 3 units. So after that, we already know our distance cn, that is gate 3. We can graph it and have this done. And remember, last time we talked about these 3 ratios in our first video, where we say if a given any angle, say sine of any angle theta is defined by opposite over hypotenuse from the right side to R. So it happens that here we have shadow for sine, when we have hana for house, and we have tar for tan. So we understand with this one, and it has our angle theta is 60 because there is a respective degree. We have sine over 60 degrees is given by the opposite from theta is degree, and the hypotenuse is 2, and that becomes answer. So let's verify using a calculator to see whether to use something similar. And let's get our calculator here. We try to press sine of 60 to see whether the answer corresponds to what we have discussed here. And indeed it is d3 over t, as you can see around here. So you can see of this getting this result that is our calculator. It is verified correct accurate b is given. So that is what is meant by special angle. But this briefly next is special angle, and that is cosine. So this gets some space here, and the angle of cosine of the given angle theta from so high is given by adversely over hypotenuse. Now we'll place on theta with 60 degrees, and this will be equivalent to or adversely having two of diagram. Here is a person adversely, that is 1. Then over hypotenuse is 2, can you there higher. Special angle 60 gives us a half again. Let's click it here and see, okay, cosine equals 60, okay, that is all. So we add plus up of this bracket, and we have 1/2. That is exactly what we have there. And with the preceding better way is we want the next one here. And that can be tangent. So tan with directly equal from Sahaja. Theta is given by opposite of what it just said. So from here, our theta is 60 degrees. Is will be equivalent to our opposite according to this angle. It's with 3 call half at the answer. Coming to this one is 1. And from there, anything about that one is the sum. Therefore, this is simply proved correct. This also go ahead and prove it and say tan of 60 degrees must leave us for 30, and exactly that is what I've just seen. Now we're done with angle 16, let's go to angle 30. So with angle 30, it's also done the same way. So let's move on and switch hands. And we have our angle 30 contour. So when talk about angle 30, we make it clear. Alright, this is our angle 30. Can expanding the opposite is an, to this angle 30, and the distance is root 3. And hypotenuse may be same as 2. So we can go on and start with our first angle, that is sine of 30 degrees. So from here, sine of any angle, theta 30 is given by opposite over hypotenuse. And here our beta is 30 degrees. So opposite is 1, hypotenuse is 2. And sine of 30 is 1/2. Again, we can check it from our calculator. Sine of 30 equals 1/2. Couldn't agree with what we have there. So it's not only cosine of angle beta is given by adjacent over hypotenuse. And we know that our data is 30 for this case here. So this is equivalent to at the destiny, adversary is root 3, hypotenuse is 2. We look at cos pattern and sine. 60 is half the same thing. And remember, 60 plus 30 give us 90. And these are characteristics of alternate angles. If we sum them together, give you 90, then their ratios must be the same. So we have again tried from the calculator to see that it is the same thing and the same cosine of pattern. Increased must give us root 3 over 2, and indeed it is. So finally, we have taken a look at the last one here, and that is term of any angle. Data is given by opposite over adjacent. So our beta in this 30 degrees is 1. Then adjacent is root 3. And slightly when you look at this without calculator, it will give you some slight difference, but of course they're the same. Let's take a look first before I talk about it more. And we have term of pattern. So the beginning has root 3 over 3. Yep, root 3 over 3, and here we up 1 over 3, and suddenly we started pondering, what happened? Now here it is nothing strange. Their span here is they're giving something like the denominator. We have value sign. It is always good to rationalize. So with last year, we multiply both the numerator and denominator by calculator, so I've just multiplied everything. So 1 times root 3 is root 3. Then pin 3 times root 3 is the same as 3 times 2, that is 9, and the square root of 9 is correct, and that is why the calculator has the we can expand or solve where we have root 3 on top, root 3 down. Still the same thing, 1 over root 3 with the same has root 3 over with, so that is one thing has to mark here. Now, these are the 6 ratios that we have learned from this triangle, and then equal to 1 triangle. So let's go ahead and consider that one triangle to see what would be the sine, cosine, and tangent of that triangle. So again, let's have some isosceles triangle. An isosceles triangle will have 2 base angles the same, and one of the triangle must be 90. So if I make something like this, this is our 90. Maybe that indicator is made. Now, it might not be accurate, but it must be. So we have this, and I joined his vectors to the other. Yeah, whereas that we have the triangle, and this triangle with the vectors A, B, and C. So this is 45 degrees. So here's also 45 degrees. If you add 45 plus 45, we have 90. And 90 plus 90 is 180, asking what sum. So we can take A that is upward here, if or angle at A. Now I think this one is a bit direct, but stick it from here and the horizon as opposite. So when we call this to be right 1, I have the 1, then the hypotenuse will be a square root of 2 uniform, right over a theorem, the sum of AC square plus BC square plus B plus AB square. Here we have here 1 square plus 1 square equals to AB square, and this one is 1 plus 1 equals AB square. So this one sums to 2 equals AB square, so you can get rid on both sides, and this 2 will have to go to the square root sign. Therefore, our AB is 7 plus bit 2, and that is what we had here. Now after that, then is to get sine of this angle 45. Go to cosine of 45. We are see a tan of 45. So how do you spend these special angles? The same way we decide we say our sine cos any angle. So this band we call them alpha, and we have given by opposite over hypotenuse. So our angle here, alpha, is 45 degrees. So from there, opposite according to this angle here is 1 over hypotenuse is root 2. So let's check from also calculator to see that it is really the same thing. Now we have sine of occupying that gives us root 2 over root. And this is the same that what I'm explaining. Carry on difference arise. This will have here. This root 2 transfer out because we were club by 1, we get the same thing. And root 2 times root 2. We still get 2 because it's 2 times 2. We can flop a square root of 4 is 2. Let's ask the next one. Yeah, that is cosine of vertex lines. And cos is given by adjacent over hypotenuse. So our angle makes 45 degrees. So this is very clear. Adjacent is 1 and hypotenuse is root 2. So if this same thing, this is equivalent to also root 2 over 2. We can check on my computer again and have cosine of 45. This must give us root 2 over 2. This is exactly what we have here. And ideally, let's have turning of any angle alpha is given by opposite over adjacent. So we have move on and substitute our alpha with angle 45. So finally, our opposite is 1, adjacent is also 1. So 1 divided by 1 is the same thing as 1. Therefore, tangent for 45 degrees is always 1. We can also go ahead and check within our calculator and save time. Or 45 must give us 1. And that's exactly what we have here. These are the most used precautions that are special in nature. That it are better if I bring the more use true travels. Now, here comes we found moment where we can also add tools more. And how do you remember this easily? We can remember this. You see, a number symbol is going to form for you here. So this have this angles here. I'm probably one walk here and that is 0 degrees. So if I have been 0 degrees, we'll go to 30 degrees, we'll go to 45 degrees, and we'll go to 60 degrees, finally 90 degrees. These are the two angles here. And then for now, soon have the angle will be say theta together with the Erasmus term here. And the interested part, side of that angle, theta, it also make cos of our angle theta, and finally we need tan of our angle theta. Nevertheless, separate this using some line, and we have a slightly bit yeah, and finally we have weak core. Now, what is the technique that we need to use in case they want to fill in? You will also listen a little bit at dinner, like that. Here is an sphere to 1. I'm going to teach you is this. What we have to do is to change from here 0 and go to 1 and until the end. So we have here t, we have here break, and lastly 4. After that, what next? We divide everything by 4. That is the next click. So we have here by 4, it's only by 4, have 2, the end here, by also 4. And the next thing here, we need to get a square root on all these numbers. So we can say a square root of the whole of this coming out here. We move on to the next one there. We move on here, and finally 2 over 4 is square root. So let's start filling in our results for the first one. Here that is 7. If we divide 0 by 4, you get 0, and the square root of 0 is 0. So this becomes our first result for sine of 0, giving us what? 0. And quickly before I use the next one, I will go ahead and show you that indeed sine 0, you get what? 0. Now let's move to the next one here, and this is factorial. A square root of 1 is 1. So when you distribute, remember, the square root certainly can be distributed. Okay, we have here 1, and also distribute 2. And square root of 1 is 1. So square root of 2 is a rational 1, so we connect it like that, can be derationalized. So here, since we have here 4, then the square root of 4 is 2. So we have 2. And this 1/2 we saw earlier on something like that. Now the next term here, we can also draw this on paper using it. By 2 to 1, 1 divided by 2 to 2. Can the square root of 1 is 1. So remember we have 2 here, the square root of 2 is this rational 1. Yeah, I mean, really, it's same. So we have root 2 in other way to handle it. Root 2 over 2, as we looked at before. Let's put the next one and say this one will reduce, so we can get the square root of the numerator and we get root 3. And the denominator is the square number, square root of 4 is 2. And that is exactly what we saw earlier on. Now we will come to this one. 4 divided by 4 is 1, the square root of 1 is 1. And indeed, sine of 90 degrees was 1. Then we can check cosine one of this special angle. We will see before. So let's go and see. 19. Sine. What is the result? We get 1. But this is our 1. Here, now, we are done with sine. How do we fill in or cosine? Here, we don't need to do any of this. Sine is extremely easy. What we have to do is to clear up these numbers, starting with 1 and bring it here. Then remove the next and bring it here. That is root over 2. Move the next one, you bring it here. And you notice something is for the sine and cosine of 45 is the same. Why? Because if you add 45 plus 45, get 90. And this is what? Often counts. So next move here and bring there and that is 1/2. So the same. 40 plus 60 get 90. Finally, we have this here. And we are done with the second ratio. Remember, for the next one, tan of any angle, theta is divided by sine of that angle, theta divided by cos of the same angle, theta. Please remember that when you come there, which this divine sine divided by cosine. So let's do that. 0 divided by 1 is 0. 1/2 divided by this. It's like we can do some small. Please plus the side here. I'm saying this is the same as root 3 divided by 2. And if I'm done, it is division sign to multiplication in the house to interchange in greater and in the remainder. Therefore, circumstance how can I read 1 over 2? Correct. So this becomes 1 over root 3. Remember, when you paste this from calculator, it's able to get root 3 over 3. And that is the result. So let's come back here and get our calculator and say, turn off. What is our angle? 30. So we press the 30. And if we give it cosine, that is exactly what I've seen there, and that is exactly the same thing also there. So let's move to the next one. 45, 1 over root 2 divided by 1 over root 3, that is 1. So time of 45 is equals to 1. Let's work this on root 3 divided by 2 over 1 divided by 2, we get here root 3. So, naturally, 1 divided by 0 is undefined. So we come back here, infinity, just like that. We can check this on this tank of 90 degrees, and you do mass error, because it's not defined. So you can say it here, mass error, and that is the reason why we've given here as infinity. So that is the one trick you can easily remember our special hour from here. Now with all this said, let us look at one example on how we can apply order test here on calculations that isn't that better to do something so we can move on. So from here, we need to have our table in us, or we'll need to have also the two angles. We talked about here because we have both on and since they were 30. So we need the two triangles And that is all what we need to answer this young radical calculator. So here you can start giving our solution in part A. The question is asking us to simplify. Would I visit the letter carry square 13 degrees minus b bracket 1 minus cos 60 degrees times sin square 45. Now what we can do here is to get term of 30 from the first diagram. Here A and then hold this B. Firstly, we need to rewrite this as term of 30 and fill out the 2 is a conclusion number bit number 1. Insert here it remains concern as 1 minus cos of 60 degrees. And for the next one here, we'll have sine of 45 squared simple out the 2 and after. So the next one here is to get tan of 30 and then go from so here. You have to number 10 times opposite about necessary. So our opposite is here and opposite is good 3. So we have 1 over put 3. That it is spared. So we move to the next one. Inside this bracket we have cos or 6. So cos is adjacent to the hypotenuse and here adjacent of 60 is 1. And we have 1 over hypotenuse is 3 and we have that. So we move to the next one here and that is sine of 45. So 45 is got in a second triangle here. And if you take it at the end, then part with this one the same. So if we are putting this, then sine is opposite. Opposite is where the hypotenuse root 2. So you have 1 over root 2. Then we can cross it over and this one is squared. So we can square this and start it with 1. We have to distribute the square with these numbers. So 1 square is 1. And is clear of with 3. Let's call it 3. So we also have minus. This one simplifies to 1 half. And the next one there is the same as 1 over 2. So if I multiply this first and it has 1 over 3 minus 1 over 4. So we have a 3 to equal this interact with later to get our answer. Let me challenge. So we have 1 over 3 and subtract this part of there 1 over 4. And it is then will just be 1 over 12. So answer is 1 12 4 with past 1. Yeah. So just look at the second one. And our second one is B. And let's squeeze it there. And this B looks like we have sine of 45 degrees. That means cos of 60 degrees all over tan of 13 degrees. So from here we can do the same thing. 45 is here and opposite of the hypotenuse that is 1 over root 2. And you multiply this or you can use a bracket like this one means multiplication and cos of 60. 60 is from this diagram and how adjacent which is 1 over hypotenuse which is 2. So we have 1 house another with it greater so we can transport it in a later. Then factor is from there. Tan is opposite over adjacent. So this is y over root 3. As we simplify the greater and move on. So here we would have y over 2 root 2 where the value die y over root 3. So multiplying that will have 2 root 2 times root 3 over so when multiplying that we have 3 over 2 root 2. And remember, it's also good to rationalize the denominator so you can multiply both denominator and numerator by this rational number that is 2 root 2. And from here you can multiply and have there as 2 root 6. Yeah, 2 times 2 is 4. And multiply this by 2. Therefore, we can also prove is 2 and 4 to 2, and if multiplying that, we will get something like this. Root 6 over 4. And that becomes our answer. If you've watched this then, thank you very much. See you in the next video. Peace out.